The new engines are pretty exciting because the base engine design hadn't been changed drastically in the past probably 20 years. But HDI recently released the GX line of engines where there's some pretty remarkable improvements. We moved from a 2-valve to a 4-valve cylinder head, and the advantage that gives you is you're able to have a stronger cylinder head. So the new 22-liter is going to have a much higher power density than the previous 22-liter. It's about power, it's about durability, and it's making sure you meet emissions. So we want to maximize the amount of power for the amount of displacement that we have. When we started getting the long blocks from HDI directly, we had to go through the process of specifying all the correct components for the major things like turbochargers, the natural gas mixers, the throttles, and all of the major components to make it a complete engine.
So basically my role is to make sure that all those controls are on the engine and they're mounted properly. One of the biggest things that I tried to focus on when I first started all this was I called around all the field guys and asked them what are their biggest challenges with our engines? What do you see as problems? What's a pain to work on? And that was the first thing that I tried to address in our design of trying to make it easier to work on.
And then we had to do all the work to calibrate those items and put all the smart guy stuff into the ECM. So we felt that we could be a good partner to HDI, taking what we've leveraged and learned in the field over the past 9 years and applying that to the engine calibration.
We have a calibration crew. We basically tell each of the engine sensors what to do and what areas are good to be in. And let's say what areas are more dangerous, like too high of pressure, too high of temperature.
It's a challenge. So meeting emissions regulations, it's a lot about sizing the appropriate catalyst, making sure that you have the right precious metal loading, and then making sure that that catalyst is well matched with your calibration. You have to marry the two together and make sure that they're going to play nice as far as air-fuel ratio control.
So to get it EPA certified, the engine has to run smoothly, consistently, and have the same emissions over and over again. And not only do they test for emissions one time, they test consistently over time too.
We want to make sure that engine package is going to be very durable, lasting 20 to 40,000 hours out in the field. And then we want to make sure that we can meet emissions the entire time and stay within the EPA requirements.
And that is the #1 job of the engineers down here, is when we roll this product out to the field guys, to the techs, to whoever is the end user of this engine, that we did our job up front to make it easy to work on.
So anybody that needs a natural gas engine to do either prime or emergency standby power, this would be a great engine for them.